for things. It's another version of moles. Right? You have the ability to do this conversion. The issue is that those units look unfamiliar to you, so you freak out, you panic, and you do it wrong. Right? This is why when we talk about this, you need to focus on the units and how you set this up. So, what are we solving for?
Carbon dioxide.
No. We're solving for gross, and ultimately gross, yeah, there it is, carbon dioxide molecules. Okay, and I'm going to do the MLCS. What are we given? 2.61 moles of carbon dioxide. Right? Ideally, what would happen? Moles to gross. That would be phenomenal conversion factor because I can get away with it in 1. If anybody can find that conversion factor, please show me because I doubt it exists. Okay? So it's not there. So we can't go to gross. So what are we going to convert moles to? Okay? Our units. In this case, CO2, our unit is molecules. Okay? I want to convert moles to molecules. Okay? How do I convert moles to molecules, London?
Avogadro's rule.
We can use Mr. Avogadro's rule, okay, which said 6.022 times 10 to the 23rd molecules is 1 mole. What happens? The moles of CO2 cancel, and I now have molecules. Okay? I don't want molecules, so I need to get rid of that unit. What do I need to convert the molecules to? Gross. Okay? And ultimately, gross molecules. How do I find that conversion factor? Not only is it given, it's literally circled to help you with that. Okay? And that's not because I'm trying to be a jerk. I'm trying to be nice and call attention to it. Almost everybody ignores the fact that that's written there. Okay? So, numbers. What number shows up in front of gross? 1. What number shows up in front of molecules? 144. What would our answer now be? Unit-wise. Gross CO2s. There we are. It's now just a question of entering it into the calculator. Okay? This question, believe it or not, even trips up tutors because they're like, oh my God, how could you possibly do that? Okay? Because again, what they're used to seeing is just following the standard unit conversions. Okay? Only using normal units. It doesn't have to be a normal unit. Okay? Follow the method gets you through it.
I feel like London's note card's just going to have Avogadro's number. Just
If anybody needs it, I got you.
I would hope, actually, that London's note card does not have Avogadro's number on it because I'm pretty sure he's going to remember it.
Every question's going to be 6.02. One of them I'll get right.
So I've always considered writing a test with like to be tricky kind of things and consider like giving it to single people as opposed to like everybody. This would be a perfect case of that. I could go through and write a test and every multiple choice answer would be Avogadro's number and I could give that to London. The problem with that is then I then sacrifice a multiple choice answer. So
Only thing wrong is everybody else would get it wrong.
Does that answer your question, Rebecca? Do you have questions any more about that? One of the things that I will say that has been tripping people up is this word units here. Okay? And I didn't realize it till well after the fact. Units has 2 meanings. Units has the meaning of what is the measurement and substance associated with a number. Okay? So in this case, the unit for 2.61 is moles of carbon dioxide. And then the other unit meaning is, this is 1 unit of paper towels. It's a single count. Right? So since we're here, and you guys can now volunteer potential changes to it, I'm thinking instead of units, I could go with things. Okay? Or objects. Okay? The issue is I don't want it to become a measurement,
Matter.
right? So it can't become a gram. Matter could potentially work. Okay, what do you guys want? Molecules doesn't work because that's now too specific. Because I can have a gross of water bottles. That's not molecules. Okay? The same deal with atoms. I can't use atoms or molecules because those are a specific thing. Okay, so we want to avoid that. It can be molecules, it can be atoms, but that's now too narrow of a definition. Does everybody at least understand what that means? So you okay with that, Rebecca? Make sense? Okay. Do we have another question? E. Let me pause real quickly here. 1.5 grams of vanadium metal reacts with oxygen gas in a combination reaction to give 2.679 grams of vanadium oxygen. How many liters of oxygen gas were reacted? Assume that the reaction was run at STP.
Oh, you can use
The thing, the formula. Okay, so what are we solving for? Liters of oxygen gas, so liters of O2. Okay, because we've already got a trigger on the thing, the formula. You now know liters being related to moles. Okay, the liters unit in that conversion should show up on top, which means moles would show up on the bottom of O2. And we know it's 22.4 liters was 1 mole, right? Yeah. Don't tell me I was wrong. That's right. Right?
Yeah.
I do screw it up, so yeah. Okay. That gets me liters, but that also brings in moles of O2. So yes, I agree, that is an awesome conversion factor. Am I given moles of O2? We'll go through and look at the numbers. I'm given 1.5 grams of vanadium metal, and I'm given 2.679 grams of vanadium oxygen. Notice that the vanadium oxygen is not specified as a formula. So if I go through and look at my given information, 1.50 grams of vanadium, I already forgot that number, 2.679 grams of vanadium oxygen, X and Y. How do I solve for the oxygen? Is there other information in the question? Say from Unit 2. In a combination reaction. Oh, I got nothing else better to do. Combination reactions, we combine two things, right? Vanadium and oxygen to produce some vanadium oxygen compound. Because it's a combination, that's how it works. I can't balance this though, because I don't know how many oxygens are present, okay, or how many vanadiums are present. So I can't balance. But that does tell me a chemical equation. Ideas? Okay, here's a hint. Let's kind of reorganize some of our information. We had 1.50 grams of vanadium, and we made 2.679 grams of the vanadium oxygen compound. Chapter 3. This fancy little law. It was expounded upon by Einstein to include energy. Really?
E equals MC squared.
E equals mc squared. What is E?
Energy.
Energy. What is M? Mass. Einstein's equation says energy is the same thing as mass. As soon as we have that, what does that then help us with? We have a law of, there's a word, conservation of mass. With Einstein, it becomes the law of conservation of mass and energy. What does the law of conservation of mass tell us? You cannot create nor destroy mass. So the mass I start with must be equal to the mass I end with. Do I know the mass of the oxygen? I don't know the mass of the oxygen. Can I solve for it? Yeah. There's my equality coming from the law of conservation of mass. I know that my mass of oxygen is 2.679 minus 1.50. To use the equation I had up at the top, though, I don't want grams. What do I want? Not meters. I want to get to liters, but I already have the conversion. I need moles, right? I would need moles of O2. I don't have the moles of O2. What do I have? The grams of O2. So I would need to do a conversion factor, and then I'd need to get rid of the grams of O2. Where do I find the conversion factor between grams and moles? Periodic table, and I find out it's 32 grams is 1 mole. Where do I get the number associated with the grams of O2? From our law of conservation of mass, 1.179 grams. Lots of bits and pieces. All of those bits and pieces are things that you've done. It's a question of stringing them together and recognizing those patterns. What's that?
I did like that, so I don't know if you remember already.
No, that doesn't work.
No?
Doesn't work because you're saying 1 mole of O2 is 2 moles of oxygen. We don't know that. You literally do not know the formula for the vanadium oxide, so you can't balance that equation. This equation is unbalanceable, which means you can't convert substances through it. You have to use conservation of mass. Your answer is wrong.
Drop the mic.
Right?
I get it.
Right. That is officially the end of class.